imagine, Amber, that this is you. Doesn't look much like you, I know. And it's a series of weights here, and what we're going to pretend is this is a smart car, is a little bicycle, and it's going to come along and clout you. What do you think is going to happen?
Maybe a broken bone or two, or fallen over?
I reckon you'll just probably get knocked over, and you'll get up and you'll probably smash the face of the bicyclist in. Yeah. Right. Now, instead of having that, let's imagine it's heavier, it's a car. So it's going to run at the same speed. What do you think is going to happen if you're now going to get clouted by a car? Still not breaking the speed limit, but you're just standing there and you're going to get clouted by a car.
This one I say broken bones.
You think broken bones. Here we go. Well, you certainly got dragged along the road quite a long way, so it wouldn't have done you an awful lot of good. Now, imagine instead that we've got a lorry. And for a lorry, what I'm going to do is I'm going to pile my carts up. So I've got the equivalent there of 6 now. So this is a lot heavier, and this is you. This is the lorry. What do you think is going to happen going at the same speed to you when you get hit now by a lorry?
Squashed or dead.
Squashed or dead. Here we go. And there you are, being dragged right along the track. And what's the difference here? The velocity was the same.
But the mass was heavier.
The mass was increasing. So the more mass, the more force. And in this case, the more force means more broken bones. From probably none with the bicycle, several with the car, and probably all of them with the lorry. And I would say if you got hit by a lorry, your chance of survival,
very slim.
That's the one. There we are. So that's the effect of mass on a collision.